All right, let's talk about one of Go's most powerful and maybe one of its most misunderstood packages, Reflect. You've probably heard about it, maybe you've even been warned to stay away from it. Well, today we're going to pull back the curtain, figure out what it's all about, and learn when it's the right tool for the job, and, just as important, when it's absolutely not. Let's get into it. So think about this for a second. You create a brand new struct, something totally custom to your application. Then you toss it over to JSON.Marshall and poof, it just works. It somehow knows everything about your struct, the field names, the types, what's inside, even though it had no idea your struct even existed when the Go compiler was doing its thing. How on earth does that happen? It feels a little bit like magic, right?
Well, the answer isn't magic, it's reflection. That's the secret sauce. It's this incredible ability for a program to look at and work with data whose structure is a total mystery until runtime.
Okay, so what is reflection, really? In the simplest terms, it's a program's ability to inspect itself.
So yeah, the official definition is right there. It's the ability for a program to look at its own structure, especially its types, while it's actually running. This is a game changer because it means you can write code that's incredibly flexible, code that can handle types you didn't even know would exist when you wrote it.
I love this analogy because it just clicks. Think about it. Reflection gives you a universal key that can unlock any data structure in your program. But it doesn't stop there. It also hands you the blueprints, so you actually understand what you're looking at once you've opened it up. That combo is what makes it so powerful.
Now, how does Go's Reflect package actually do this? Well, it all comes down to two fundamental concepts, type and value.
Okay, let's break this down. On one side, you've got reflect.Type. That's your blueprint. It tells you about the shape of the data. So if you have a variable age, the type doesn't care that it's 30. It just tells you, hey, this thing is an int. On the other side, you have reflect.Value. This is the actual thing, the data itself. This is what holds the number 30. So remember, type is the blueprint, value is the actual object built from it.
And you know what's cool? Getting a hold of these is super simple. You just take any variable, literally anything, and pass it to reflect.Type of to get the blueprint, or reflect.Value of to get the actual value. That's it. Those two functions are your entry point into the whole world of reflection.
But just looking at things is, only half the fun. Where reflection gets really interesting and also a bit dangerous is when you want to modify values on the fly.
So this brings us to the concept of settability. A reflect value is settable if you can actually change the original data it's pointing to. And there's one huge rule here. For a value to be settable, it has to be addressable. All that means is that Go needs to know its real address in memory. If you just pass a variable by value, reflection gets a copy, and changing a copy is useless, right? So it has to be addressable.
So there are really two big rules you have to follow. First, like we just said, it's got to be addressable. You can't be working on a temporary copy. Second, and this is super important for structs, the field you want to change must be exported. It has to start with a capital letter. This is Go's way of protecting private fields. Even with the power of reflection, Go won't let you just stomp all over a type's private business.
Okay, so how do you actually do this? It's kind of a four-step dance. Let's walk through it. First, you need a pointer to whatever you want to change. This is what makes it addressable. So instead of just x, you use and x. Step 2, you pass that pointer to reflect.Value of. Now what you have is a reflection object representing the pointer itself. To get to the thing the pointer is pointing at, you have to call .elem. Think of it as dereferencing the pointer. And boom, now you have a settable reflect value, and you can use methods like .set to change the original variable's value.
All right, so we've seen how powerful this is. It feels like a superpower, right? But, and this is a huge but, every superpower has a cost. With great power comes great responsibility, and we really need to talk about the hidden costs of using reflection.
There are three big reasons to be super careful. First, you completely throw away Go's biggest advantage, type safety. The compiler has no idea what you're doing, so if you try to set an integer field with a string, it won't complain at compile time. Nope, it'll just blow up with a panic when your code runs. Second, performance takes a nosedive. We're not talking a few percentage points here. Reflection is way slower than regular code because it's doing all this work at runtime instead of compile time. And finally, the code just gets harder to read. Your teammates will look at it and have a much tougher time figuring out what's going on.
And just to show you what I mean about performance, take a look at this. This isn't a subtle difference. Normal Go code is fast. That's one of the reasons we love it. But the moment you start relying heavily on reflection, your performance can absolutely crater.
If speed matters at all in your application, you really have to think twice before reaching for Reflect. So after all this, the power, the pitfalls, it all boils down to one simple golden rule. If you remember one thing from today, make it this.
Here it is. Don't use reflection unless you absolutely have to. It's that simple. Now, what does have to mean? It means you're writing code like the JSON package or a database driver, code that by its very nature has to work with types it can't possibly know about ahead of time. That's what reflection was built for building tools. It's not for your day-to-day business logic.
So before you type import reflect, stop and ask yourself two questions. First, can I solve this with an interface? If not, then ask, can I solve this with generics? Honestly, 99 times out of 100, the answer to one of those will be yes. And you should always, always prefer them. Think of reflection as the emergency glass you only break as a last resort.
So there you have it. You now understand the universal key. The question is, what are you going to do with it? The mark of a truly senior developer isn't just knowing how to use powerful tools like reflection. It's having the wisdom and the discipline to know when not to. So what will you build? And maybe more importantly, what will you choose to build another way?